So at this point, I am going to do the 3, if not 4, multiple choice problems. So if you're having some trouble with these types, then you can go through these with me. Let's see. So average or mean value of a function means at that point they want you to use the actual mean value. So the mean value of the function formula would be 1 over b minus a, integral from -1 to 2 of 3t cubed minus t squared. See? So first thing I'm going to do over here, I'm going to find my antiderivative. Looks like 3/4 t to the 4th minus 1/3 I meant. 1/3 t cubed. I'm going to need f of 2, which would be 16 to 4/12 minus 8/3, which 36, so that's 28. 36, okay, and then f of -1, -1 to the 4th power, so that's just 3/4, -1 to the 3rd power would still be negative, so that becomes positive 1/3, and then this one, common denominator would be, make that 9, make that 4, so 13/12, and this one out of 12, multiply that by 4, and we get 112. Subtract those. Let's see, so we get 99/12. Alright, so come back over here. I did a lot of work off to the side. 1/3 times 99/12. That'd be 1, that'd be 33. So I think I get 33 over 12. Divide them by 3, and we get 11/4. But notice, if you forget about that 1/3, it will be 33, I think this is 33 over 4. So if you forget about the 1 over b minus a, you end up with the wrong answer, which is D. Alright, finding an integral of a piecewise function, you would simply do the integral from -1 to 0, and that would be the x plus 1 function, plus the integral from 0 to 1 of the cosine of pi x. So you're just doing 2 integral questions. We don't really care if it's going to be continuous or not. You're going to find the area, the net signed area of this curve, and then you're going to find the net signed area of this curve between these values, and add them. So antiderivative of this guy would be x squared over 2 plus x. F of 0 is 0. F of -1 is 1/2 minus 1, -1/2. In this one, the antiderivative. So this would actually be a substitution rule. Your u is pi x. Du dx is equal to pi. So du over pi is equal to dx. So this would become, I'm just going to come over here. So we end up with the integral of the cosine of u times dx, which would be du over pi. So I'm going to just put that over pi. I can even change my limits. So my limits would be from u of 1 would be pi, and u of 0 would be 0. And some of you may have gotten pretty good at not having to do the substitution. That also works. In this case, the antiderivative, so everything's in terms of u, so I'm not going to use x's anymore. So the antiderivative would be sine of u over pi, f of pi. Sine is 0. F of 0. Sine is 0. So I believe we end up with, down here, this integral is 0 minus -1/2 plus 0. Interesting. And the answer becomes D. Hopefully I didn't make any mistakes there. Number 12. So there's a k oddly stuck inside of my antiderivative, or sorry, my integral. So I don't know exactly how to do the problem, so I'm just going to start out with finding the antiderivative of this guy. So that'd be 1/8 x to the 8th plus, if that's a constant, then the antiderivative would be with an x, 2. So I would get 2 to the 8th over 8 plus 2k, and f of negative 2 would be negative 2, oopsie, that's supposed to say to the 8th, which is the same as positive 2, over 8 minus 2k. So f of 2 minus negative 2 to the 8th over 8 minus 2k. So this would cancel because that actually turns into the same because it's an even power, and I get 2k plus 2k, which just gives me 4k. So I solved the integral, but notice it said equal to 16, so equal to 16, therefore k equals 4. And I believe there's one last one that might not even be in your packets, but I wanted to go over a calculator problem. An object traveling in a straight line, if the initial position, so that's an initial value, and the velocity is this guy, what's the position at time equal to 3? So position at 3 means I need to know a position at the beginning plus the integral from 0 to 2 of v of t dt. And this is a calculator problem, so you would place this into either y1 or the blank screen. S of 0 is 2 plus the integral from 0 to 2, whoopsie, cube root of 1 plus t squared dt. Alright, so those are the problems that I promised you. There you go.